The engineering behavior of the soils is greatly influenced by the amount of water present in it. To study this behavior, we note down the two properties known as liquid limit and plastic limit. The liquid limit of a soil is that water content at which the soil ceases to behave like a liquid and it gains infinitesimal small strength. At this point, the soil is coming from liquid to a plastic state. The laboratory determination of the liquid limit is carried out usually by a liquid limit device, which is shown here. By using this device, we take a soil pad which is placed in this cup, and at the center a groove is made of the specified size using the standard tools. The soil is then allowed to flow from both the sides by giving jerks using this knob. Now, the liquid limit as per this determination is that water content at which, if the soil in this cup is given 25 number of blows, the two parts of the soil will flow towards center and just meet. Another method which is used for determination of liquid limit is the cone penetrometer method. Now let us first see what is the equipment required for determination of liquid limit by the cone penetrometer. This is the cone penetrometer. It has a base, a spirit level to check the horizontal of this base. This whole assembly can be moved up or down using this clamp, and the penetrations are noted on this dial, which is graduated in 1/10 of the millimeters. For example, here this is 0 and a total movement of up to 10 indicates the penetration of 1 millimeter. There is a standard cone with which the penetration is made into the soil. This cone is made of stainless steel. It has a very fine tip, and the dimensions are as shown in this diagram. It has an apex angle of 30 degree with a permissible variation of ½ degree, and the total length of the cone is 35 millimeters. This cone can be clamped here such that the total weight of the cone with its assembly, which will be allowed to fall, is 80 grams. Now let us see how the soil sample is to be prepared. For the preparation of soil sample, we require IS standard sieve of 425 micron size. This sieve is placed on the top of a pan, and the soil sample, which has been obtained for determination of liquid limit, is placed in the sieve. It is then covered with the lid, and then it is shaken for a few minutes so that some sample will pass through the sieve. The sample passing through the sieve is collected. So this is the sample which we have obtained after sieving. Now about 150 grams of the sample is required for preparation of the specimen. The sample is prepared by adding some water and mixing the soil with water thoroughly so that a paste of uniform consistency is obtained. This paste is then transferred into the cylindrical container made of brass. This container has specified dimensions. After transferring the soil in this container, the top surface is flushed to give a smooth appearance. This cup now is placed at the center of the base. Now the tip of the cone will be brought in contact with the top surface. By moving this clamp, we can lower the cone and the finer adjustments are carried out by using this clamp. Now to check as whether the tip of the cone is just in contact with the surface, you can see the reflection from the surface should just coincide with the tip of the cone. Now at this stage the sample is ready for penetration. Now first let's note down the initial reading, or we can bring the pointer to 0 level. This is the automatic penetration timer. With this help we can release this cone exactly for the 5 seconds, which is the specified duration. By operating this switch, this release knob will allow the cone to penetrate into the soil. After 5 seconds, it automatically locks the release knob, and now you can note down the final reading by lowering this rack on the top of this guide and the final reading may be noted. Now the difference between final and initial reading will give you the amount of penetration. Now we know the penetration of this cone. The second step in this exercise is to determine the water content of this sample, which is done by the oven drying method. For this purpose, we take a empty aluminum container, the weight of which is known to us, and some sample from this container is taken, and the weight of the wet soil can be recorded. This balance is of the capacity of 200 grams and sensitivity of 0.01 grams. Now after noting the weight of the container with the wet soil, we'll keep this into an oven at a temperature of 105 to 110 degrees centigrade for 24 hours, after which you can note down the dry weight and the moisture content can be determined by making simple calculations. In this method, we take 3 or 4 sets of reading such that different penetration between the range of 14 to 28 millimeters are obtained. Now these readings have been recorded in a performer which may look like this. The penetrometer recordings, initial and final, the difference of which gives penetration, and the corresponding to each penetration we determine the water content. So we have about 3 or 4 sets of such readings. The penetration is then plotted against water content on a semi-log graph, taking penetration along x-axis on the log scale, and the water content in percentage is plotted on the y scale, which is on the simple graph. Now the different points which are plotted, they are joined, and mostly a straight line relationship between water content and penetration is obtained. Now from this graph, corresponding to a penetration of 20 millimeters, you can note down the water content. This water content denotes the liquid limit of the soil sample. The determination of liquid limit by the cone penetrometer also has been standardized by Bureau of Indian Standard, and detailed specifications have been laid down. This method has a few advantages, because whereas in this method it is difficult to find out the liquid limit of the soils which contain appreciable amounts of sands, with cone penetration it is simpler to determine. Using an automatic timer reduces the chances of human error. Further, in this method, the accuracy is largely dependent on many factors, which includes the accurate filling, the accurate cutting of the groove, and the accuracy in the height of fall. Whereas this method is comparatively free of the procedural errors.